Hello everyone. Let's go ahead and go over the do now for today. So, number one, ask you to simplify. And here we have to simplify a binomial with two terms and it's being squared. The mistake here is to say, oh, I squared a -3 and I squared this, and maybe some of you got, I don't know, 9. Maybe you got 9 plus 2x minus 1 because you did that kind of squaring method. This would be incorrect. This is absolutely wrong. We got to make sure that since it's a binomial, we understand what that means to square a binomial. I will actually write this out in expanded form, and looks like -3 plus 2 root x minus 1 times -3 plus 2 root x minus 1. And now, this very obvious now that we probably need to do some distributing, foiling, box method, however you want to call it. So let's just go ahead and do that. -3 times -3, that gives my 9. -3 times 2 root x minus 1, -6 root x minus 1. 2 times minus 2 root x minus 1 times -3, and another -6 root x minus 1. And finally, 2 root x minus 1 times 2 root x minus 1 becomes plus 4x minus 1. And let's combine like terms here. We have 9. This in the middle two terms become minus 12 root x minus 1. I'm going to distribute here to get plus 4 minus 4. Almost done. Combine like terms one more time here. I forgot the x right there. So then 9 and 4, that makes my 5 plus 4x minus 12 root x minus 1. All right, let's go and solve the second problem. So when I look at problems like these, I instantly recognize I have a second power, a first power, and a zero power. This is a trinomial. So we should all know that at this point, we see a trinomial, we're going to factor it. We're going to try to factor using a big X. So I'm going to try to get this term, my highest leading degree, -2x squared. I want this term to be positive. So I'm going to add 2x squared to both sides. So I get 0 equals 2x squared plus x minus 1. And now we just have to do the big X. So 2x times x will give you us 2x squared. And then -1, my x is going to be positive, so I need the 2 times a positive number to be bigger. So I'm going to put a 1 here and then -1 there. Just check here, 2x times 1, 2x. -1 times x, -x equals x. Good. So my factor form is 0 equals 2x minus 1 times x plus 1. I solve 2x minus 1 equals 0, or x plus 1 equals 0. 2x equals 1, x equals 1/2, or x equals -1. And that's it for your do now. Please go ahead and flip your paper to the back side. We're going to do 3 practice problems together. That's going to be similar to the type of problem on your homework 11 through 16. Once again, flip to the back side of your do now, and we're not going to work on some similar problems to numbers 11 through 16 from your homework. All right, so we're dealing with double radicals sometimes. So we have radical on the left and a radical on the right, square roots on both sides. I mean, to be honest with you, in this case, this is actually the most friendly method because we don't have any constants here. There's nothing outside, no coefficients. There's no constants in the back, just radical and a radical. So all we gotta do to get rid of the square root is we just square both sides. The square and square root, they are inverse operations, they cancel out. So I'm left with just 3k minus 29 equals 41 minus 2k. And this is a really good, this is a perfect scenario because it's simple to solve. I'm going to leave that solving to you, but we're going to move on to another type of problem. Now, looking at this one right here, this time we have a radical on the left, and you guys probably all know from yesterday, oh, we should probably minus 3 to both sides. Let's do that. Square root 5y minus 15 equals y minus 3. So now everyone from yesterday should be like, oh, okay, I know how to get rid of the square root. I'm going to square both sides. Square and square root cancels out. I get 5y plus 5 equals. let's make sure now, that's what we did to do now, to remind you when you are squaring a binomial, two pieces, I gotta make sure I do my expanded form. You gotta understand that this is y minus 3 times y minus 3, 5y plus 5. Oh, minus 15, my handwriting. It's a minus 15. I'm sorry about that. Let me erase it. Minus 15. So that's now going to equal to y squared minus 3y plus 9. You can pause videos and solve on your own, or you can just keep going with me. 5y minus 15 equals y squared minus 6y plus 9. Got to move all my terms to the right because my leading term y squared is positive right there. Minus 5y plus 15 plus 15. So I get 0 equals y squared minus 11y plus 24. Let's do that big X. Y times y. I think this is going to be minus 8 minus 3. So y minus 8 times y minus 3 equals 0. So y equals 8 or y equals 3. You might think we're done now. But remember, we have to go back and check for extraneous solutions. You gotta make sure you check for extraneous solutions. So I'm gonna take this 3 and plug it back all the way to the original equation. Do some mental math with me, okay? Do some mental math with me. 3. 5 times 3 is 15. 15 minus 15 is 0. Square root of 0 is 0. 0 plus 3 is equal to y. That means 0 is equal to 3. Y is 3. Good. I mean, I can also write it out if it makes it better. So, for example, 5 times 3 minus 15 plus 3 equals y, so equals 3. And you'll see that this whole thing ends up the left equaling the right. So 3 is a valid solution. Okay? Let's go ahead and also check 8 just in case. Just in case. Let's plug in 8 here. 5 times 8 is 40. 40 minus 15, 25. Square root of 25 is 5. 5 plus 3 is 8. Equal to y, which was 8, so 8 equals 8. So both are good. In this example, we don't have any extraneous solutions, so both are good. All right, our last problem of our examples here. Now, once again, this time we have a double radical on the left side and the right side. However, we have a constant on the back, right there. Well, what that tells us, it's going to be more work. We have to do squaring of both sides twice. But that's a start. Let's just start by doing the work here. So we know we have to square the left side to get rid of the square root there. But I mean, I got to square root the whole thing on the right. So the square and the square root, they cancel out. I'm left with q minus 21 on the left. Binomial on the right, root q plus 7. Let's make sure we have to distribute. Root q times root q is actually just q. Root q times 7 plus 7 root q. 7 times root q plus 7 root q. 7 times 7 plus 49. Okay, let's go and continue to solve. Combine like terms. Q minus 21 equals to q plus 14 root q plus 49. Okay, let's see. Okay, so now we see this root q as our last square root left. So we're going to get rid of the q, get rid of 49, get rid of the 14 after that, and then get rid of the square root and try to solve at the very end. We are almost there. More tedious for sure. So we're going to minus q. Oh, we're going to minus q to both sides to get rid of that. We're going to minus 49 to both sides. So that cancels out. Q minus q is 0. I'm left with negative 70. Oops, row 60. Negative 70 equals 14 root q. That's square root. That's divide both sides by 14. plus root q. I believe negative 70 by 14 is negative 5. Okay. Let's finish the problem. We have a root q. Let's get rid of that root by squaring both sides. So we get q is equal to 25. Well, hold up. Let's go back and check our answer to make sure it's actually good. So do some mental math here with me. Plug 25 in. 25 minus 21. 4. Square root of 4 is 2. We're good on the left. Let's plug 25 in here. Square root of 25. 5. 5 plus 7. 12. So 2 equals 12. That doesn't quite make sense. So what does that tell you about Q? Yes, so in this case, Q is probably an extraneous solution. Or not probably, it is. And that's it for our examples. Please go ahead and try number 11 through 16 by yourself. The answers on Google Classroom, please check as you work on them. Thank you.